Hello everyone. So in this lecture we are going to learn about the searching algorithms. Basically there are two types of search. One that is sequential search and the another one is binary search. Sequential search is nothing but the searching algorithm that we use in our day-to-day life. Let us say like we are searching for some item, so we one by one check with each and every item and we match it. If that match found, that means we got the item, right? So that is a sequential search. So let us take a basic example. So suppose we have an array and I have stored the items, let us say like 23, 9, 15, 47, 32, 51 and 17. And if I want to search, let us say I want to search for item 32, right? So my key is 32, right? So whatever element I'm going to search, that would be considered as my key, right? So what I need to do is like this is my array A and I'm having the index that starts from 0, 1, 2, likewise. So I need to match my key, right? I need to compare my key with A of I, right, starting with 0. So that means this key is 32 and I'm matching it with A of 0. And what is A of 0? That's 23, right? So here 32 is not equal to 23. That means I didn't found the match, right? So what I'll do, that's a I plus plus, right? And I plus plus, that means that I is incremented, so I am having this 1, right? So now I'll compare it with A of 1, right? So 32, again my key is 32, I'm comparing it with A of 1. A of 1 is nothing but 9. Again the match is not found, again the I is incremented, now I is equal to 2. The same way I'll compare it with A of 2. A of 2 is 15, again 32 is not equal to 15, right? Again I plus plus, right? So now my I, that is equal to 3, right? Again A of 3 is 47. 47, again that is not equal to 32, right? Then again I incremented, now I is equal to 4 and A of 4, that A of 4 is nothing but 32 itself. So 32 equal to 32, so that means here the match is found, right? So this is the basics of a sequential search. If someone says that what is the algorithm of it, so it's a simple for loop we are applying, right? So first we compare the key, right? We need to compare key and A of I, right, for the each element of I, right? So if the it is equal, that key and A of I is equal, then match found. Otherwise if not, then I need to increment my I, right? And so on, that steps are repeated again and again and again, right? So this is about sequential search, right? If we talk about the best case of it, right, so the best case complexity is big O of 1, right? So why? Because best case means in the my very first attempt I'm getting the answer, right? Suppose I am searching for 23 and my key is 23, so in the very first attempt I'm getting the answer, right? So the best case time complexity is O of 1, right? And if we talk about the worst case time complexity, worst case, that means either I'm getting either I'm not getting my data, the key is not available in the list, or it is available in the last position, right? So that is the worst case. So the worst case complexity is O of n, right? So this is about sequential search. I think you understand it. So now let us move ahead with the binary search, right? So if we talk about binary search, right? So this is one kind of searching algorithm. So first thing, that is in a binary search, that it will be applicable in the sorted elements only, right? So if we don't have a sorted element, so the first step we need to sort it if we want to apply a binary search, right? So it is applicable to the sorted element only, right? Then what we do, that it's like we are dividing the entire array, right? So for that we find the midpoint, right? And for finding the midpoint, the formula is low plus high divided by 2, right? Let us take one example, that suppose I'm having an array, this is like randomly I'm taking it, right? It is in the ascending order because it must be sorted, right? Then and only then I can apply the binary search algorithm, right? So here I am having indexes. So first I need to find the midpoint. What is low? Low is nothing but the lowest point, and high is that the highest index, right? So it's like 0 plus 5 divided by 2, so that's a 5 divided by 2, 2.5, and that's integer value is 2, right? So this is like mid is equal to 2, so this is my middle point, right? Now what we do, that we find we compare the key element. Till now I have not decided the key element. Now suppose like I want to search for 85, right? So my key element is 85. So I need to compare key with A of mid, right? So here my A of mid is what? 2. So A of 2, right? My key is 85 and A of 2 is 57, right? Now we need to compare it, both are equal or not, but obvious this is not equal, right? That means I am not getting my answer, right? Now I need to check whether my key element is greater than or less than A of mid, right? Here in this case, key element 85 is greater than 57, right? That means I can say that this element is available to the right side, right side of my list. So we are dividing the list into two parts. This is the left part of the list and this is the right part of the list. It is compared with 57 middle element, it is not same. So now it is going towards like a key element is greater than A of mid, so it is going towards the right side, right? So in a right side I am having this 72, 85 and 90. For this iteration, this is like 3, 4 and 5. For this iteration my low is 3 and my high is 5, right? Again I need to repeat the same thing, right? What I need to do, I need to find a mid for this sublist, right side sublist, right? So that is 3 plus 5 divided by 2. So 5 plus 3, that's a 8. 8 divided by 2, that's a 4. So now my mid element is 4. Again, what I need to do, I need to compare my key element with A of mid. Now here my mid is 4, so A of 4. What is A of 4? That's 85, right? And what is my key? 85. Both are equal, that means the match is found, right? So here I have found the match. If not, maybe if I'm searching for something else, right? If not, then again I need to go for that whether my key element is greater than or less than the mid element, right? And in such a scenario we need to check whether we need to iterate, we need to do recursively the steps for the left side or a right side, right? We are dividing the list, right? So it's a part of divide, right? So we are dividing the list and then we are going towards, suppose if this is not 85 and 34, so we'll compare. This 34 is greater than 57. No, it's not, right? 34 is less than 57. So instead of going towards the right side, we need to go towards the left side, right? So this is like basic thing, right? And like we need to go for the range, right? Low is equal to like m plus 1 and that high is equal to max, right? So I hope you understood this. This is a basic searching method, sequential search and binary search. So I hope you understood it, right? Thank you very much.